going to talk about the two-proportion z interval there. Okay, so the form here is going to be p hat 1 minus p hat 2 plus or minus z star times square root of p hat 1 q hat 1 over n1 plus p hat 2 q hat 2 over n2. Okay, so this is going to be the form. Now, from your video notes over the weekend, you have seen this difference in the proportions, right? The p hat 1 minus the p hat 2. You've also found the derivation of the standard deviation of the statistic. But I need you guys to realize that this is just statistic plus or minus crit value times the standard deviation of the statistic. If you guys look at your bright orange formula sheets, this is already on the formula sheet for you. You do not need to memorize the p hat q hat over n plus the p hat q hat over n. It's already there for you. Okay, so if you want to take out that bright orange formula sheet and you want to take a look at the very bottom on the back page, it goes from 1 sample to 2 samples. So Will's taking his out. May I borrow this for a second? If you want to look, it's right in the middle section. It says difference of sample proportions. It's going to be this one. And over there to the left, or to the right, excuse me, you see the p hat q hat over n plus p hat q hat over n. Now, on your formula sheet, it just says p then 1 minus p over n, but you need to realize that we're talking about the sample proportions there, right? But again, this confidence interval formula is not changing. It's the statistic, except this time your statistics are the difference of sample proportions. All right, so your statistic's a little bit bigger than it used to be. So is your standard deviation of the statistic. But the general concept is the same. Okay, so that's what's new about this, right? Okay, conditions for inference. This is when 2 sample differs from 1 sample. One of the major differences is that there are 2 samples versus there is 1 sample. That's why we call it two-proportion z-interval, because those 2 proportions come from 2 random independent samples, or 2 randomly independent assigned groups. Okay? Do you guys see this word independent and this word 2? That's going to be the new random check. You need to make sure that the data that you are looking at are from independent sources. So they're separate by assigned groups, or they come from 2 different samples. They have to be from separate entities, all right? Because if not, it could be a paired kind of deal, all right? And I believe in your notes you talked about paired versus not paired, or paired versus independence, okay? So it's very important to be able to read and assess that. That's going to be where you get a little bit tricked up. Normality check, you've got to check all 4 of these. N1 p hat 1 greater than 10. N1 q hat 1 greater than 10. N2 p hat 2 greater than 10. N2 q hat 2 greater than 10. So you must see that all of those successes and failures are above 10 with the statement. All right? Let's continue on there. All right, so our example today, we're only going to do one example because it's going to take a little bit. All right, many news organizations conduct polls asking adults in the United States if they approve of the job the president is doing. Have you guys ever seen those polls? Because oftentimes they do them like once every 3 months. It's like called the president approval rating. They randomly sample like 1,000 U.S. citizens and they say, what do you approve of the job the president's doing, or you disapprove of the job the president's doing? And they kind of keep track of that over time. I think they do at least 4 samples a year, if not more. All right, but here you go. So did President Obama's approval rating change from August 2009 to September 2010? So according to a CNN poll of 1,024 randomly selected U.S. adults in September 2010, 50% approved. And a CNN poll of 1,010 randomly selected adults in August 2009 showed that 53% approved. So what we're assessing here is we have 2 different samples. You guys understand that there's 2 different samples and they're independent. Why are there independent samples here? Why are they independent?
Because yeah,
True.
there's your one person is
And how do you know they're independent? How do you know that one doesn't affect the other? They're different times, right? One's in 2009, the other's in 2010. Right? So they're from separate years. Okay. What we're interested in looking at is use these results of the polls to construct and interpret a 90% confidence interval for the change in Obama's approval rating amongst all U.S. adults. So what was the change, aka the difference in this? All right. And then we're going to have a follow-up question talking about, is there convincing evidence to say that those approval ratings changed or not? All right. So that convincing evidence almost sounds like a hypothesis test, but we're not doing one. So we're going to use our interval to conclude something afterwards. All right. So if we're going to do a confidence interval, we are going to panic. All right. First part of panic is parameter. This time we want to estimate the true difference in proportions. We want to estimate the true difference in proportions. Instead, we want to estimate P. We want to estimate the true difference in proportions of P sub 10, and we're going to use P sub 10 to represent 2010 minus P sub 09 to represent 2009. Now you could do P sub 2010 if you want. I just did the last two numbers, 10 and 09. Okay, and we're going to do that with 90% confidence. So guess what we're going to have to do here? We don't have just one parameter. We have two. So we have to state both parameters, where P sub 10 is going to be the true proportion of all U.S. adults who would approve of President Obama's job performance in August 2009. We don't want to say who approved of, because who approved of means that they were part of the sample. So I want you to think about this phrasing right here. Who would approve? Because you didn't ask every U.S. adult in 2009. You just asked a random sample. So if you were to go back to, quote unquote, 2009, hopefully that sample is going to be representative of all U.S. Americans who approved of the job he was doing in 2009. So guess what we're going to do for the next parameter? Rinse and repeat, but we're going to put not August 2009, but August or September 2010. Because one was in August, the other was in September. Like I said, it's not difficult, it's just tedious. Right? You have to list out both of them every. Hey, you're going to get really good at parameters, though. Making sure you word them correctly, make sure that you write them out correctly. Yeah, I know. When you guys were complaining about the one sample, I was giggling to myself. I was like, they have no idea. Hey, you're going to have very good hand dexterity by the end. So just think of it like that. It's like you're doing 90s, but just one giant problem, right? What comes after parameter? Assumptions. Oh, you guys need some time to copy?
Yeah.
Okay. All right. Assumptions. First, new big change. You are looking for how many samples? 2. You were looking for if they come from independent sources. Do we know they come from independent sources?
Yes.
Are there 2?
Yes.
Great. We're going to say that there were independent random samples. Not simple random samples, because that's different. You don't know if it was a simple random sample versus just a random sample of some sort. So they're independent random samples of 1,010 U.S. adults in August 2009 and 1,024 U.S. adults in September 2010. And then we must check normality. Oh, I'll do this one with you. the proportion who approved of the job rating in 2009? So what was P hat sub 09? That's 53, so 0.53?
Yeah.
So that means that P hat sub 10 must be 0.50, correct? So we gotta check, so based off the sample size, remember, what's your sample size in 2009? 1010, right? So you need to do 1,000, well, you can first write this if you want to. It's N09 times P hat 09 greater than or equal to 10, which is going to be 1,010 times 0.53, which is greater than or equal to 10. And using my calculator, I got 535.3 is greater than or equal to 10. Is that correct? Someone verify that as I do the other one. Thanks, Maggie. So that means Q hat of 09 is going to be 0.47. So 1010 times 0.47 is 474. Greater than or equal to 10. Come over here. N sub 10, P hat sub 10. Greater than or equal to 10, right? So I got to take what? 1,024. Take half. It's by 12. You guys know that's true for N sub 10, Q hat sub 10, right? Why is that true for that one as well? So I have 535.3, 474 point something, and 512. All those bigger than 10?
Yeah.
Yay! So what can we say there? Therefore, the sampling distribution of P hat sub 10 minus P hat sub 9 is approximately normal because there are at least 10 successive failures. Did you write the statement, Henry? You did not write the statement, Henry. Henry, write the statement. You know, I'm going to check Henry's test to see if he wrote the statement. Let's see if he wrote the statement as he was.
I didn't write the statement.
You did not write the statement. I don't know. We're going to check. Don't say it out loud if you didn't. Why? You just thought that writing the statement was just optional, right?
Oh my God. Did you say it out loud? Or do you give any expression whatsoever they would give the reveal? What if I did
So what are you going to do?
You don't
You don't even know. Let's just say there was a good, valiant attempt at writing the statement, but there were a couple of things that were left off. So I think Henry still needs to practice, along with everyone in the room, about writing the statements, correct? Okay. Cool. Now, if you got 100 on the statement, I'll get on your back. Yeah, no.
I still do.
Okay. All right, guys good? Assumptions?
Yeah.
Okay. I mean, I want you to be real with me. Do you guys know how to do this?
Yes.
It's just what? It's tedious. I get it. I got that it's tedious. I know. Okay. Two proportion Z interval. Let's go ahead and
Very different.
do this one here. Here now, at number 6. Two proportion. Z interval. 6 down. 8 to go. Oh, that was some calculus.
Yeah, thank you.
It does not come by in 3 months. After that, your art gallery disappears. Okay. All right, so I want you guys to go to your calculator. Stat, tests. I want you to go peruse your calculator, and I want you to find the button that says 2 proportion Z int. And that's the button that we're going to use today. Notice it is conveniently labeled 2 proportion z int. I wonder if we should use that one for the 2 proportion z interval. The answer is yes, absolutely. We should definitely use that one, right? So let's go ahead and get to that menu screen, right? Okay, go ahead and write this down on your paper. So this is going to be the test statistic that we're going to use, or the confidence interval, rather, that we're going to use. And then we are going to plug and chug. Okay, we're going to plug and chug. So you guys told me that 2010 was 50%, and then 2009 was 53, correct? Did I get those right? I'm trying to do this from memory. Does it say that? 2010 is 50. All right. So that means that this should be 0.5 minus 0.53. It's terrible, 0.53. I'm going to fix it. Plus or minus. Okay, what kind of confidence interval are we doing? The level?
90.
And we're talking about proportions, so we're using the normal curve, correct? So what's the 90% Z-star?
1.615.
You guys remember about a month ago when you were like, oh my gosh, I have to memorize all these? You guys remember that? Yeah, you did. You totally did. You guys now remember. See, look, I told you, like, give it a little while. You remember. Okay, fine. Only Anna says it. Okay, so.
Oh, I'm offended. My name's Henry.
Literally the same.
What was it, 1010 or 1024? 1024. Are you trying to use your calculator as a cell phone? Call the authorities.
Let's see one day. Door blocks. We
Okay.
don't have any anti-bully posters in here. Not cool.
Will you make me some?
Yeah. I
Okay.
might see it. You'll all see.
All right, do you guys see? This is,
Whoa. Back up.
oh boy. All right, do you guys see us type it into the interval? Or plug it into the interval. And now it's time to use our calculator. Okay. You guys ready to do our calculator?
Yeah.
Okay. Give me a second. I'm going to pull up the calculator here. TI 84. You guys can go ahead of me if you want to. I mean, you could look at the screen and see if you can figure out what to type in at least, right? I got 71 days left on my free trial.
Oh, I thought you said
I was like, what are you talking about?
Yes, 71 days until spring break. Yes. That's what it does. Okay, but anyways, you're over here at stat. We're gonna go over the tests, and where are we at? Number B, right? Number B. Letter B. Okay. Do you guys see X1, N1, X2, N2? All right, it's got to go in the same order in which you plugged it in. All right. So if we do p hats of 10 minus p hats of 9, 10 must go first.
Yeah.
Does that make sense?
Yeah.
So this one, so 2010 is going here. 2009. But you cannot put in a decimal for the number of successes. You can't put in a number decimal, so you're gonna have to round. So for the first one, I think it was what, 512
Yes.
out of 1024. Is that correct?
Yeah.
But for the next one, it's not. What was the number of successes for when we checked for 2009? 535.3. Okay, do you guys want to round that up or down? It doesn't matter. No, that's not a trick question. It doesn't matter because it's going to be approximately the same. You could do 535 or 536, and you're going to get the question. You want to do 535? Okay, sure. And then that's at a 1010, right? Change our confidence level to 0.90. Calculate. Okay. So you can go ahead and write that underneath where you plugged in everything. Okay. So our interval here is going to be negative 0.0661 to 0.00674. So negative 0.0661 to 0.00674. You guys good with that? You see where I came up with all that? Excellent. Okay. So let's go back here. To the actual board. Notice up here, I actually did all of this on the PowerPoint already. If you want to make yourself a note here, that x1 and x sub 2, those x sub 1s, x sub 2s, those are the number of successes. If you really want to make, I really encourage you to make this note. They cannot be decimals when you plug it in. That's why it says 535 or 536. Because you're going to get credit either way if you round, up or down. So this is what we typed in, correct? And then we got this. It's going to say you can't do it. You can try. It's just going to be like, meh, can't do it. It's going to get finicky. Kind of like AP Stat students the first time I show them a 2 proportions Z interval. Oh my gosh, so much writing. Yeah, I know. I love you guys. I do. I fuss at you with love.
Yeah. Cool.
All right, so what are we going to conclude here? So do you guys remember the C part of FANUC? Panic. FANUC. Panic. Not since our p-value is less than or greater than something, because we don't have a p-value, we don't have an alpha level, right? So what's the other conclusion? We are 90% confident that the interval from negative 0.0661 to 0.0067 captures the true difference in the proportion. This is going to be the next big nitpicky difference. The true difference in the proportion.
At some point, can we do a practice? Just identify what these to use.
Oh yeah.
Okay.
Yeah, we're going to do that. We usually do that closer to the AP exam because I'm going to add in like 2 sample, chi-square, 1 sample. Linear regression is really easy to pick out. It's the one with either a linear regression table, plot, or an XY table. Pretty easy. The ones that are hardest are the 2 sample t-test versus the matched pairs t-test. Those are the most difficult to differentiate.
Which ones versus?
2 sample t versus matched pairs t. Because they both deal with 2 different things. But the question is it from 1 sample or 2? And are they paired in a certain way? But we'll get there, Karen. Don't worry. But yes, we will practice the what to use when testing procedures. I have a nice little thing that we usually do in review, but we'll probably be able to do that in class since we'll have some time left. Yay us. Oh yeah, tomorrow's review. Yeah, that's right. I forgot. 4th period wanted sampling, design, and experiment review. That's what they said. What do you guys want? That's the first thing that we did in the course. Like types of bias, experiments, whatever. There's either that or we're just going to do some multiple choice random practice. I was just going to give you some other things back to them. What'd you say?
I remember, except normal curve. I should have been doing that. Is that always all that is?
That was most of chapter 2. Z-scores, normal curve. Yep.
What did y'all do last week?
What did we do last week? Sampling distributions. Kind of like what your video is on, except we did it for 1 sample, not 2. I was thinking either chapter 4 or just some mixed review. I was just going to print off a couple non-release free responses and say, here you go. Can you do it? And we'll go and see how it happens. One of those 2 things. Anyways, let's finish this, shall we? I'm sure our YouTube subscribers are really bored by this random conversation that we're having. Yeah, we're still on. Yep. You guys take forever to write, so I fill the time with my, random conversations. All right, so what does this mean? It's from negative to a positive, right? What does it actually mean? So let's talk about question part B here. Based on your interval, is there convincing evidence that the job performance has changed? Has changed. Now we need to use the interval to kind of help us figure this out. So I have a question. When would we know it has changed? If it wasn't.
Lies beyond.
If it's not within the
What you guys say it. If it's not within, what is it? Because what did we do to these? We subtracted them, correct?
true difference.
Okay. So how do we know there is a difference? It's not equal to 0, as in the interval would have to be greater than 0. The whole interval would have to be above 0. Or the whole interval would have to be below 0. So that means if it was 0, what does that mean if you take a difference and you get 0? There is no difference. So I have a question. Does that mean that the job approval rating has changed if 0 is inside the interval? No, because there's evidence it hasn't changed, right? Okay. So I want you to write this down. There is no change if 0 is inside the interval. There is no change if 0 is inside the interval. That's because 0 represents no difference between two things. It's kind of like this. On your little performance task in chapter 9, let's say that Henry made an 8 out of 10 on one, and then an 8 out of 10 on another, and then an 8 out of 10 on the last one. Did his performance change over time? How did you know there was no difference? Because he got the same score. AKA, also known as, if I take the difference within one score versus the next, 8 out of 10 minus 8 out of 10 is what? 0. There is no difference. He did not change. Because if he did change, let's say he got an 8 out of 10, learned from his mistakes, got a 10 out of 10, did it change? Yes. What did he net? What was the result? He went from 8 out of 10 to 10 out of 10. He improved by 2 points because 10 minus 8 is 2. You guys see that? So if there is a change, that means that 0 is not in the interval. So let's go back here. Is 0 in the interval? Yes. I have a question. Does that mean we have convincing evidence that it's changed, or do we not have convincing evidence it has changed? We do not have convincing evidence it has changed. So what does that almost sound like from hypothesis testing? Like we do have evidence, we do not have evidence. Like what does that sound like when what we do? It sounds like the statement. Well, what's the statement of we do have evidence? Yeah. So if there is a change, 0 is not inside, we're going to reject that claim, right? Reject HO. If there is no change, that means we fail to reject HO. So if 0 is inside, you do not have evidence that it's different. If 0 is not inside, you do have evidence because it's either going to be all below, meaning that his job approval rating decreased over time, or if it's all positive, it increased over time. Does that make sense? Here, we have some negatives, we have some positives, aka we do not have evidence it did change, or at least statistically significant evidence. All right, you guys with me on that? Okay, because you're going to get a lot of follow-up questions that are very similar to this, all right? All right, and that wraps up two proportions interval for today. You learned some stuff? Maybe? No? All right, right, again, homework is going to be on page 622, 612, 14. Yes?